Hey guys, so this is part 2 of 7-6, and we're going to be looking first at this example of how to tell when you have a table if it's going to be linear or exponential. So when we did linear functions, we checked to see if I'm adding the same number each time on the x's and on the y's. And we said if I am adding the same number each time, then it's linear. So now we're going to look at how exponential is going to be different from that. So first we're going to see how many I'm adding each time on both top and bottom, or both x and y. So we'll start with that. So to figure out how many we're adding, right, we take the difference. So 2 minus 1, right, is 1. So I'm adding 1 here. 3 minus 2 is also 1, so I'm adding 1 here. 4 minus 3 is also 1, so I'm adding 1. So I'm adding the same amount each time. That's good. We always want to be adding the same amount on the x's. Doesn't matter if it's linear or exponential, we want to be adding the same amount on the x's. On the y's, let's see how many we're adding each time. So if we do 1 minus negative 1 is the same as 1 plus 1, so that's 2. 3 minus 1 is 2. And 5 minus 3 is also 2. So we're adding the same amount each time. We're adding 2 each time as we go. So this table represents a linear function because we're adding the same amount each time. So let's check and see. Let's do the check we would do if we're trying to see if it's exponential. So to see if it's exponential, we're actually going to divide the y's. You still see how many you're adding in the x's, but you want to see how many you're multiplying by in the y. So to see how many we're multiplying y, we're going to divide. So if I'm always going to do the second one, or the later one divided by the earlier one. So for this first one, it's going to be 1 divided by negative 1. So 1 divided by negative 1 is just negative 1. So that's another way of saying if I multiply negative 1 times negative 1, I'm going to get positive 1. And then I'm going to do that again for this pair. So 3 divided by 1. 3 divided by 1 is 3. So if I multiply 1 times 3, I get 3. 1 times 3, I get 3. And then I'm going to do 5 divided by 3. So 5 divided by 3 is 5/3. It's not a nice number. That would be approximately 1.6. But I'm just going to write it as 5/3. It's 5/3. So in other words, if I multiply 3 by 5/3, I'm going to get 5, right? So if I had done all that and these had been the same, then this would have represented an exponential function. But because they're different, because these are different, but these are the same, it's a linear function. So that's the difference. That's what we're checking here. If we're adding the same amount each time, then it's linear. If we're multiplying by the same amount each time, then it's exponential. So that's what we're going to be checking each time when we're looking at a table and trying to see if it represents a linear or an exponential function. Okay, so let's continue. So in this question, we're again looking to see if it's linear or exponential, but instead of having a table, we have an equation. So in this one is actually easier because one thing we know about exponential functions that I haven't mentioned yet, but we have looked at the form of an exponential function. But if the x is in the exponent, then it's exponential. So if the x is in the exponent, then it's exponential. It's true for all variables, but it's, I think, easy to remember with x. So if the variable is in the exponent, then it's exponential. If you have something of this form, y equals mx plus b, we talked about that when we talked about linear functions, so that's the linear form. So this obviously doesn't match this. This doesn't have an x in the exponent. So this is exponential. This equation is exponential. This would be the form if it were linear. So it's going to be exponential. So looking at our exponential, we know that exponentials have this form. We talked about that in the last video. So we're going to identify our a and our b. So a in this case would be 3, and b would be 6. So this might be a situation where I started with 3 candy bars, and then my candy bars multiplied by 6 every day. I'd have a lot of candy bars. That's a ton of candy bars. But that would be the kind of situation. You're starting with 3 and then you're multiplying by 6 each time. All right, so then we wanted to check and see if this equation follows those 3 rules we talked about. So a is not allowed to equal 0. Well, a is 3, so that's true. B has to be greater than 0. Well, b is 6, so that's also true. And b is not equal to 1. Well, b again is 6, so that's obviously not. That's also true. So since these 3 things are true, and it's in the form that we know for an exponential function, the x is in the exponent, this is in fact an exponential function. So in this video, we've talked about how we can tell from a table if something is an exponential function. If we multiply the same thing each time, it's going to be an exponential function in the y. If we multiply the same thing each time in the y, we're always going to be adding an x. But for y, we're going to be multiplying by the same thing each time if it's an exponential, adding by the same thing each time if it's linear. And then if we have an equation, we know it's exponential if the x is in the exponent. All right, I will see you guys in the next video.